Hey, good morning, everyone. I think we'll get started there. I can still see there's a number of people logging in and joining the webinar, but I think it's just past 11 o'clock now, so we'll make a start. Well, welcome to this morning's webinar, which is covering the decarbonisation of heat, specifically looking at heat pumps and their capabilities to deliver demand-side flexibility. First off, apologies for the croakiness of my voice. I've caught a cold from my children's nursery. It's not COVID, fortunately. I've had a few tests, but just apologies for the croakiness of the voice in my introduction. We've got a lot to cover this morning, and hopefully we'll have a lot of questions from the audience. So I'll try to keep my preamble to a minimum, but I just want to introduce our speakers before we get started. First off, I'm Andrew Langlands. I work in the account management team at Flexitricity, and I'll be hosting the session this morning and putting your questions to our panelists at the end. And first off, while I introduce everyone that's on the panel, I'm going to hopefully launch a poll here to gauge what your level of interest in heat pumps is. So hopefully that is now visible for everyone to start responding to. Just asking whether you've already got heat pumps installed, whether you're actively considering installing heat pumps, whether heat pumps are something you're considering installing at some point in the future, or whether more information is needed before you consider heat pumps, or if you know what's a heat pump, you're just here for interest, really. So introduce you to our speakers. Our first speaker is Dave Pearson. He's Sustainable Development Director at Star Refrigeration. He leads the team responsible for heat pumps at Star Renewable Energy, as well as Star Data Analytics, which focuses on driving value through better data analysis of working heat pump systems. So he'll be here to talk to us about his experience of working heat pumps in action. Next will be Dr. Alastair Martin, who founded Flexitricity in 2004 and is now our Chief Strategy Officer. Recently, Alastair's been involved in discussions with government and industry bodies, including BEIS and the Association of Decentralised Energy, emphasising the role that flexibility can play in the decarbonisation of heat and transport, which will very much frame today's conversation in a wider electricity system perspective. And then we'll hear from Dr. Roddy Yarr, Assistant Director in Sustainability and Environmental Management at the University of Strathclyde, where he's responsible for developing the university's response to net zero. Roddy leads the Sustainable Strathclyde team, which has deployed a bold and innovative climate neutral districts vision, which involves 100% renewable heat, power and travel across all university assets in the central belt of Scotland. So he'll be here to talk to us about that and some of the projects that he's involved in. Feel free to submit questions throughout the webinar. There's two ways you can do that. We would recommend using the Q&A function, which you should see on your screen. There is also a chat function, so we'll have both of those open just to capture anything that gets sent through. As I say, preferably use the Q&A, but you're welcome to use the chat as well if you want to pop anything on there. So before we set off, I'll end our poll here. It seems like a reasonable split between the kind of first three options of already have heat pumps installed, but the majority, about 2/3, 60% of people on the webinar are either actively considering installing heat pumps or are considering installing heat pumps at some time. So let me see if I can share the results there. So yeah, that's a good way to lead into you, Dave, and with a lot of people actively considering heat pumps. So what I'll do at this point, I will hand over control to Dave, and I will introduce you to our first speaker.
Thank you. Well, very pleased to be here. It's quite a journey that I'll try and describe as well, but one of the best bits about it is meeting interesting people along the way. So at some point in the last 13 years, to be perfectly frank, I can't remember when, but clearly not before 2014, I met Alastair and we got chatting about flexible stuff, and that stuck in my head for quite a long time as to what the potential for this is. So what I'll give you is a little bit of a story today as to what's been going on over the last 13 years or so. But I'll start with half a quote. The man who invented the hamburger was smart, by that luminary genius, Matthew McConaughey. We'll come back to that at the end. This is a cartoon that obviously has popped up fairly recently, but it really just strikes me as the scale of the challenge we've got. And we're somewhere in between focusing on the red and the blue, but actually it's the green one. Optimist that I am, I think the world has learned a lot of things of how to mobilize and actually build back better, and such expressions perhaps give me a glimmer of hope that we might be focusing on the right stuff and the big stuff sometime fairly soon. But of course, a lot has gone on even before we get here. This is quite an old clip taken from the European Heat Pump Association of the advantages of heat pumps. And everybody likes to share lots of different reasons for doing stuff. And depending on the audience, we might be talking about local jobs, or we might be talking about energy efficiency. But here, this is all about the one on the right, which is smart grids. I added on less imports because that's something I think any economy needs to be thinking about, the macroeconomics of your energy system. Importing 50% now of the gas that we burn, which is a sum total of about £20 billion in the UK, is quite clearly not. It's a bit like Scotland play football. It's giving the other team a 1-0 start before you get going, and that never ends terribly well, does it? So as I just click forward with this, the thing about heat pumps and heat, the difficulty is it's in lots of different places. This is some slides I was doing at the time for some folk in Dumfries, and just even thinking around the borders of Scotland, there's a vast diversity of different house types, different building types, industrial processes, a small whiskey still there as a graphic. But that's the challenge of how to bring this technique into all these different places. And clearly, one of the key things we want to do is do it as cost effectively as possible. And that's you can do anything well or badly, as the case may be. Sorry, the clicking is just going a little bit slow here. Here we go. So some folk have heard of heat pumps. I've got this in the style of Vic Reeves' statistic that 50% of the world have heard of heat pumps, and 50% have heard that they don't work very well. But that's something that we're trying to dispel. Taking a very simple one, and this just is really there to demonstrate that policy is at the core of the challenge and the opportunity. This is a brand new house, a clip I've lifted from somewhere. We are still building brand new houses with gas boilers in them. That's the sort of scale of the challenge that we've got. And across these other segments, if we get the right policy, we can do the right things. So we could build this brand new house with some nice tulips in the front garden, and it would be off and running as low carbon. So Star's bit, though, is very different from that. We're not in domestic heat pumps. I happen to have one in my house, but that's just because I'm a bit of a heat pump geek. And it's, I have to say, it's running very well. But our business got into heat pumps around about 2008, 2009. Some clients approached us and said, we're thinking of doing this project in Norway for district heating. And my first comment was, what's district heating? I'd never heard of it, to be perfectly honest. So we got involved in it. We realized that if we used ammonia as the working fluid, we outgunned the competition using cousins of CFCs, basically, by about 25%. So this client is now buying 25% less electricity because they used an ammonia heat pump. We also had the challenge of getting up to a fairly high temperature. And this was the first 90-degree heat pump in the world. It's still the largest 90-degree heat pump even 10 years later. And that says lots of things. A, it was good, and B, gosh, it's quite difficult to repeat success. So it's taken us a while, but we have moved forward and much closer to home. West Dunbartonshire Council and the area of Clydebank. This is the former John Brown shipyard area that's being redeveloped over the next few years, but they have deployed effectively something similar to Drammen. We're taking the heat from the River Clyde and raising that up to 80 degrees and delivering heat into the district heating network that will feed the entire area. The buildings will not be served with gas, I don't think, and they'll be getting their heat from that. But you know, why bother? Well, when I put this slide together, I said it's roughly about 45% of the carbon footprint of gas. Actually, on some days it can be 2%, because obviously the Scottish grid is incredibly decarbonised. And so the site is built. This is quite an old photo, actually. I should pop down and get some nice new ones, because it's all been landscaped. It's a lovely plaza. The lower left corner, sorry, is before the heat pumps even went into the facility, and there's space for 4 heat pumps, and 2 have been installed. So these are what I affectionately call the twins. I kind of felt we were rearing them in the factory in Thornliebank in Glasgow, and then they were passed over to their new owners, and we're very proud that that's happened. And Vital Energy are the main contractor on the site, and did a brilliant job of quite literally picking these up and taking them and deploying them. And the key thing about the district heating is the other bits, and really it's the other bits I want to talk about today. But these particular ones, there is no NOx emissions, because they're not burning anything. Obviously created local jobs. The key thing, and this is really the pertinence of today, it actually allows more wind generation on the grid, because we have a very flexible consumer. In the foreground of this photo, you can see the electric motor. These are each 800 kilowatts of electric motors. Now that in one sense is a challenge, because it's a big electrical cable and it's a big load. But in the other sense, it's a huge opportunity, because we can switch the heat pumps off in less than a second. And that's the bit I'll come on to in a bit more detail. We haven't as yet harnessed the cooling effect, but these heat pumps are cooling down river water, and that is not being used. We're only keeping the heat from the river water that's boosted up to 80 degrees. So perhaps at some point somebody will ask for some cooling on the site. We can flex around the time of use and aim for the cheapest tariff. And once things settle down in site, that's, I'm sure, something that they'll be looking at. But as I said, we're delivering 3 units of heat for every 1 unit of electricity. And depending what date you take, and there's a real cluster of dates being thrown around, but these units are 2050 ready, if that's the date you're picking. Or in Scotland, of course, we've got targets for 2045, or various cities now are saying we need to be 2030 ready. We will not have to go back and revisit these and run them on a different fuel, or make them do something different. We are producing heat that is 2030 ready, and that started tail end of last year. So 10 years ahead of schedule, so well done to them. So the key bit about this is energy storage, and there's some brilliant guys in this industry, very inspired by Henrik Lund and his colleagues, in particular David Connolly and Brian Vad Matthijssen. But if you're interested in any form of energy storage, look them up. They're in Aalborg University in Denmark. I learned a lot from them over the years. And one of the things we learned was that energy storage is incredibly important. And you can do it different ways. You might have a Tesla battery, and that's great, but you can see in the left-hand column, the y-axis, the cost. Or you might have a large-scale battery facility, and that's great, but it costs that much. Or a variety of others. Closer to home, pumped hydro is clearly a technique that we know in Scotland. But what the guys in Lund are saying, in Aalborg, sorry, are saying is, actually, if you're going to turn that electricity into heat anyway, storing it as heat is a far better way of doing it. So at a very domestic level, a small tank in a house will cost you this much. A larger tank will cost you that much, and it's cheaper. And then the sort of centralized district heating, and even in Denmark and some of the cities now have effectively a football pitch sized thermal store. We don't have that in Clydebank as yet, but if I put these to the same scale, of course, that's the comparative cost. So you can see it's very, very much cheaper to store heat as a thermal component, a thermal vector, than storing as electricity. And so this is zoomed out a little bit, and you might be drawn by the telehandler, or you might be drawn by the building, and it's absolutely stunning. You might be drawn by the flue tower. There are backup boilers, of course, and they've done a good job of that in the ventilation system. But actually what's important in this picture is on the right-hand side, this thermal store. And I'm going to say a little bit about that in the closing part. So thermal storage, why is the question? Well, we can forcibly turn on the heat pumps, even if we don't need heat, and store the heat. Or we can forcibly turn them off. If we've already got a thermal store, we can turn the heat pumps off and save it. But just how valuable is that? Well, 1 megawatt hour of heat storage needs 29 cubic meters. 1 kilowatt hour is 29 liters, therefore, and 1 cubic meter gives us 11.5 kilowatt hours of electricity that we can switch on or switch off. And we have 135 cubic meters in that tank. You can see, much like the Father Ted sketch of these ones are small and those ones are far away. That tank is absolutely gigantic, but quite far away. So that's giving us 1.5 megawatt hours of electrical switching that we can enact when we choose. As I said earlier, we can turn it off in less than a second. And we can also control the demand output and trim down to about 33% capacity. So is this just a freak case? You know, we're only ever going to see one of these systems in Scotland. Well, that's a policy decision. It's down to whether we create the right political environment and the policy. And there's some really good stuff coming through that's picking up on this success and going forwards. But what about the technical aspects? Well, this is some really good work done by Greenspace Scotland and Park Power, basically showing clusters of heat demand and the proximity to water, and where these could be picked up and delivered, and effectively cousins of Queen's Quay created. We did some work under the banner of Heat Vision 2030 for the centre of Glasgow, and basically said, if we create heat networks with 4 heat pumps, a bit like the Twins, then could we create district heating across the centre of Glasgow? And the short answer is absolutely yes. The technology is 100% proven. What we need is a commercial platform in which to do that. And that's why the private wire is so incredibly important in this, and also the flexibility. So I think this is maybe my second last slide, but the vision that we have is that we have cities, but we have heat pumps perhaps on barges, but connected, direct coupled to the offshore wind farms. And there's a brilliant analysis that shows that the windier is, the more electricity you can make, but also the windier is, the more demand you have in the cities. And so that's a great time to be buying electricity, because it should be at its most abundant. Equally, if the wind drops a little bit, and with thermal storage, we could probably back off and still meet that lesser demand. So back to Matthew McConaughey, the man who invented the hamburger was smart, but the man who invented the cheeseburger was a genius. So with that, and as intro to the next speaker, Alastair, and to try and big him up, really what I'm saying is, in the words of that other philosopher of our modern time, Norman Cook, heat, flex, save, repeat. So Alastair, I'll pass over to you.
Thank you very much. I've never seen anybody bring Fatboy Slim and a log scale graph into the same presentation, so that's an achievement. Thank you for that. And Andrew, I think you're going to advance the slides for me. Thanks for that.
I will indeed, and I'll just remind everyone that they can continue to submit questions throughout via the Q&A or the chat function. But yes, I will control the slides for you, Alastair.
Nice one, thank you very much. Okay, so Flexitricity, our job in Flexitricity. It's to find flexibility on the demand side of the electricity equation. And that means energy users. It also means small generators, and it also means batteries. And to deploy that flexibility to help balance electricity networks. So we're connected to district energy schemes, to cold stores, HVAC systems, liquefaction plants, and many others. And we've got a control room running 24 hours a day, and it's earning money for those customers as we and they help to keep the lights on. That is demand side flexibility, and sometimes called demand response. A lot of that flexibility comes from heating and cooling. So if you jump a slide, please. We've been doing this for 13 years now. Some of the events we deal with are big, such as Tilbury catching fire, just as it was ramping up during the morning pickup one day a few years ago. Now, all but one of our customers were called upon to help fill this hole, which was 400 megawatts in size. This event unfolded over several minutes. But sometimes, Andrew, if you could jump to the next one, things happen very fast. This is the relatively new NEMO interconnector, which runs between England and Belgium. It's quite reliable. In fact, it's really very good, but everyone can have an off day. And this is what happens when a gigawatt of infeed disappears. Frequency drops very fast. That's the blue curve. And the speed at which it falls, the rate of change of frequency, is the orange curve. Falling frequency can lead to a blackout extremely quickly. That means that some of what we do, some, but not all, has to happen inside a second. Next slide, please. These events still occur, but with the grid greening up, the demand side has new duties on top, and that's balancing the natural ebbs and flows of renewable electricity. And here, much of what happens more slowly over minutes and hours. And it's not all about shortfall. During the Beast from the East, we saw about 28% of GB electricity coming from wind. And solar can do well as well, even in winter. These graphs are all from a recent bunch of Christmas days, showing solar output in those times. And the highest of the lot is higher in output than Hinkley C nuclear power station will be able to produce when it's commissioned. So renewables can be very high. These are situations when demand is also fairly high, but renewables can be high when demand is low. And they can also vary. So other times there is less renewable energy available. These changes have a large effect on electricity prices. Now, I'm not talking about tariffs there. I'm talking about the wholesale and the spot markets and the balancing mechanism, the markets that underlie the tariff prices. So prices change a lot. And the closer to real time you are or able to act, the more certain you can be about whether a price is high or low and whether or not you can respond to that and capture the value of it. There's another point, which is that it is often windy in Scotland. And there's a lot of solar generation across southern England and South Wales. And sometimes the networks can't carry everything that we want to flow. So some of it gets wasted, and that's expensive. And all of that, if you can jump a slide, has profound implications for heat. As Dave has said, heat can be stored far more cheaply than electricity, and it's usually much better at handling short variations in feed and supply. So the pictures here are all of well-known CHP schemes. And I'm not going to speculate on what the individual plans of the operators of these schemes may be, but we all know what decarbonisation means for most heat networks. And that is a move to large-scale heat pumps. So if you're in the business of turning electricity into heat, the call to you from me is to recognise the value in the way that you do that by operating flexibly. All heat networks have some inertia, most have heat storage, some have a lot, and all of that has value. Some of the things that electricity wants from flexibility are technically challenging, and some are subject to strict rules, or they're just really fast. But not everything is like that. I sometimes come across energy managers and other energy professionals who have heard one particular demand flexibility pitch. They have determined that their assets can't do that particular pitch, and they've abandoned the whole idea. Now we want to avoid that sort of missed opportunity. So the way I think most heat pumps should operate is on the next slide. It starts with capacity, the capacity to consume electricity or to not consume, an appraisal of whether or not any of the contracted balancing services like frequency response or reserve could be offered, and if so, how much and when. And that generally means a commitment of some kind from 1 to 30 days ahead. Then it's all about setting up the daily operating plan with a mixture of forward or curve trades and day ahead auctions. This then sets up what the heat pump is intending to do if nothing else changes. But this can be changed right up to real time through the intraday markets and the balancing mechanism, as you see on the right, as we vary the schedule to suit the change in prices and the needs of electricity. And that is where much of the value of flexibility is created. So the next slide shows the balancing mechanism. We're going to show a couple of example periods in the balancing mechanism. In the balancing mechanism, anyone who signed up to it can trade, but they can only trade with National Grid. National Grid is the counterparty. And the BM, the balancing mechanism, is split onto the bid stack on the left, that's people willing to buy energy, and the offer stack on the right, people willing to sell it. And selling can mean turning down consumption. So the green ones here are BM trades, or BOAs, as they're called, which were made in that half hour. Some of ours are circled, and one at least of those is a district energy scheme. Next slide shows the opposite. So another period when Grid was trying to get rid of energy. The circled trades are actually our customers getting paid to stop generating. And in fact, in there is district energy that's getting paid essentially to rely on its heat storage. That's a great moment, clearly, to start a heat pump. But the BM also carries a true locational element, which most electricity markets don't. So if you're near the renewable generators and the transmission network is highly loaded, you will get called out of the regular price order. This is one such period. The green list on the left goes way off the page, with ever increasing negative prices achieved, in this case, mainly by wind farms in Scotland. So I'm a great believer in putting green energy to work, and I want to see heat pumps soaking up that energy. Next slide, Andrew. So these markets, the BM in particular, they can be very active. The BM sees thousands of trades each day. This shows 1 day of CHP activity in district energy. The red line is what the energy centre planned to do. The black lines show extra energy bought in the balancing mechanism, all of which are within the limits of the site, which are the blue lines, and those limits can change operationally at any time. And every day is different. Some are quiet, some are busy. It all depends on the day and on the plant itself. The next slide shows some very fast customers in the balancing mechanism. In this case, it's a battery, which can shift very quickly. Batteries get a lot of activity if they're priced right. But what I want out of this webinar is a procession of large-scale heat pumps entering the balancing mechanism and the intraday market, gobbling up the greenest and cheapest energy around and helping out electricity networks while they do so. What we're doing is moving electricity around in time. We're responding to events and to opportunities, all within the constraint of the heat network itself. Optimization means meeting heat demand at lowest cost, and that means we'll be using green energy to warm people's homes, and that is what we're for. Next slide, please. Fine, how do you get in? There are 4 routes in. You can do some things yourself if your site is large enough and you're able to make commitments to go with reserve, frequency response, or capacity schemes. But this isn't the way that most single-digit or even double-digit megawatts generally go, because the overhead is too high. Most people will look to aggregators to bring them into these services. As Flexitricity was the first open market aggregator, and we are still extremely active in that space. But many of the markets, the balancing mechanism, intraday, day ahead, they require an electricity supply license to access. So we've been a licensed supplier for 3 years now, concentrating on flexible business customers. Some of these things are now offered by other suppliers, but it's not the norm. Most electricity users aren't thinking about flexibility, so most suppliers don't concentrate on flexibility. The new thing here is the final column, the virtual lead party. The short version, and you don't want the long version, the short version is that a VLP can offer a site into the balancing mechanism without being the electricity supplier for the site concerned. So we were the first active VLP, and that is because we recognized that not everybody wants to change supplier when they get into flexibility. Our first VLP capacity joined our supply capacity in the BM about 2 years ago. There's a couple of other, on the bottom there, a couple of other revenue options that I haven't gone into. One is helping to de-stress distribution networks, the lower voltage networks, and the other is the capacity market. In that latter one, the capacity market, some care is needed because the rules are very complex, but it is open to heat pumps. And now distribution network services, on the other hand, are highly location specific. But if you have a plant in the right place, you can help save on network capex, and there's value in doing that. And in fact, we already have district energy schemes participating in exactly that way in distribution network services. There are moves to blend between things like reserve and the balancing mechanism into distribution network services. So watch the space for more on that. 4 routes in, take your pick. The best choice for one site won't necessarily be the same for another, but the one thing is clear, flexible operation is a must-have for heat networks and heat pumps. Because, actually last slide, Andrew, thank you. A net zero economy needs a fully decarbonized electricity system, and whichever technology choices are made, that means a lot of flexibility of different forms is required. These numbers come from National Grid's future energy scenarios projections. They're going to refresh those scenarios early next month. Okay, whatever the power networks need, they pay for. And for heat pump developers and heat network developers, that means better rates of return, lower bills for your customers, and genuinely green home and business heating. And that is the point at which I will stop and hand over, I think, to Roddy.
Thanks, Alastair. I'm Roddy Yarr from University of Strathclyde. Thanks for having me along this morning. I'm going to give you a perspective from, I suppose, a university point of view, but also as a user perspective as we move towards a net zero position, or do our best to get towards that position. Hopefully I can move the slides on myself, or perhaps could you move it on, Andrew?
I've hand control over, so hopefully if you're able to click on the screen, you should be able to move on to the next slide.
Okay. I'll move on here, but not. There we go. So yeah, hopefully I did that and not you, Andrew, but yeah, let's see how we go. So yeah, first slide, I guess, is the university has installed a district energy scheme. Lots of universities have done that. Lots of universities have done several schemes now. We were quite late to the party in terms of getting a district energy scheme in place to help us to create a more efficient energy system, but also one that saves us cost, I guess. And at the time when this was done, there was a reasonable carbon saving compared to our existing buildings all being powered by individual gas boilers. So we're able to generate our own electricity, as many are familiar with in terms of CHP. But since the climate emergency was declared, our burning of gas was clearly not a sustainable way forward. However, we have installed that network in the city centre at our John Anderson campus in Glasgow. So we've been through the pain of installing district heating in a city centre. So that's important to get into our experience portfolio. It's a small but purposeful scheme, connects 18 buildings at the moment. It was connected to 16, we extended it to a further 2. And we may extend it a little bit further to make it more efficient. But our trajectory is very much now moving away from how to get off gas and onto other more sustainable energy systems. So that's kind of the direction of travel. But I think the important point is we have a network in place that we can use to connect into a wider district heating scheme for the city. We future-proof the network so we can pump more water through that network. We have a thermal store as well. We could have more thermal stores as well, to David's point earlier, which is important. I'm trying to move forward again. So what are we doing now? I think is important to recognise, and I think our approach really is to reduce our demand side. So get our buildings in a much more efficient place so they can accept heat at lower temperatures. They're much more efficient in their fabric, I guess, and that's standard practice, I guess. But it's something that we have to do, and lots of our university peers are on this journey with us to how to decarbonise their existing estate. And we have 37 buildings across our assets across the central belt of Scotland. In an agile world, now we're looking at space utilisation, how we make our estate much more efficient in that sense. But also we need to think of different ways to do what we need to do to get to a net zero position that's also climate resilient. I think that's important to think about as well. And our approach here is a whole systems approach. It's at scale collaboration with city partners because we can't do this on our own. And we need investment to get into this space. And what we do has to be deliverable and has to be de-risked so that investors, private and public, will be able to make this transition happen. So yeah, we're doing a piece of work now, just about to appoint a consultancy team to do a lot of work around our existing estate, look at the technical options available to us to get the demand side down from some of our buildings. And if you've been to Strathclyde University, you'll recognise some of the buildings in the diagram here. So we're strong in that piece in terms of knowing that we need to do a lot of work to get the answers to what we need to do, to rank the costings of those and to make them deliverable and keep the university operating, because obviously we can't close the university down. We have to keep doing this work and keep students and research going, keep that teaching model going, and it has to be deliverable as well. So yeah, we're installing lots of on-site renewables. Several projects have just finished over the past week or two. The James Weir now has solar on top of it. The Sir William Duncan, the business school, we've already got some in place already. And our new National Manufacturing Institute down at the airport, which is coming out of the ground, is going to have solar PV at scale on top of its roof and in the car park. So we're trying to do our bit there to make our estate work for us a bit better. Any new build will be passive in its design. So the new TIC building that we're planning at stage 3 REBA design will be passive house, ideally passive house plus, and will also be well building certified. and will be adapted to the changing climate as climate change is locked in to some degree. So that's our kind of direction of travel. We will be making all of our buildings much more energy efficient from the get-go, and our design teams are helping us to do that. We also think about embodied carbon, so we are trying to reuse as many of our buildings as we can rather than build from new. So again, that's an important point, but perhaps not so relevant to today's discussion. So yeah, collaborating, that's a really important point for us. We get the fact we can't do this on our own, and we are collaborating at scale to help that endeavour. So one of our examples of that is the work that we're doing out down at the National Manufacturing Institute, where we are doing our first energy carbon neutral in operation building at the new institute that's coming out of the ground. As I said before, there'll be no gas connection to the gas grid. That will be heated and powered using renewables, heat from the sewage works, working with Renfrewshire Council's ambient heat loop from Lay Park sewage treatment works, and we're the anchor load for that development. So we've put our hand up to help that transition to happen, along with the Medical Manufacturing Innovation Centre next door, which is also planned, and also the electrical side being using solar PV with battery storage as well. So a collaboration, I guess, which is under construction. So this is again, I guess, an exciting time for us as we deliver that new institute. And I think this is my last slide. This is a piece of work that we're doing in the city centre with partners, and including Dave, I have to say, and a consortium of experts helping us to design a climate neutral city innovation district, taking heat from the Clyde, thinking about how we distribute that heat to businesses and organisations within the innovation district, and including residents that are around the borders of that district, which is an entrepreneurial zone. So very much a partnership, collaboration, thinking about 100% renewable heat, power, transport, adaptation and well-being for our community. So our kind of place in that is to create a bit of a thought piece around how can we transition that district as an exemplar that's replicable across the rest of the city, and kind of show that we can do this, we can enable this to happen, and think about all of the aspects that we need to think about in that transition. Infrastructure, integrating within existing city plans, de-risking the investment, but signalling the pipeline of opportunity around this space, and thinking about where low carbon heat and power can play into that, and using waste heat as well where possible. So yeah, I think that's all my slides I think I've got to present. And thank you very much.
Perfect. Thank you very much to all of our speakers. We're going to move on to the Q&A section. There's a number of questions that have come through, so thank you very much. I would ask, please feel free to continue to submit your questions either in the Q&A function or in the chat. The first one I'll ask is for both Dave and Roddy, from Mike Joyce. What are your experiences of people's attitudes to connecting their home/business to a heat network? Do some choose not to connect, and how do their energy bills work once they are connected? So I don't know if Dave or Roddy wants to come in on that one first.
I'm happy to give a comment. I can't speak for Queen's Quay because I'm not on the client's team that's grasping with this, but involved in a lot of projects around the UK. Generally speaking, if a building is being influenced by planning applications, then it's quite easy for them to say, yes, I will, because they kind of have to. Buildings that are already existing are under practically no obligation as yet, although it's changing very quickly. Two pieces of work to keep an eye on: heat in building strategy and the heat and building strategy. And I get them mixed up, which is the Scottish version, which is the rest of the UK version. But they're basically going to, and one has been published and one hasn't, but they're basically going to put the thumb screws on buildings to improve their carbon footprint. So in that sort of next half decade, I think it's going to be a lot easier. In terms of the billing, that too is very complicated. Schemes before now, if they did connect to these sort of systems, or the operator would have taken advantage of the renewable heat incentive. And that basically was a fiscal balancing mechanism from the government to overcome the fact that electricity is comparatively expensive to gas. And even with your superb efficiency of a heat pump of, let's say, 3 to 1, if the electricity is 5 times the cost of gas, that's not a good day in terms of cost, unless you can claim the renewable heat incentive, of which there's the domestic and non-domestic. And that balanced it up and made the heat essentially cheaper, of course, with the infrastructure costs. That is finished. Quite what's going to fill the gap, nobody knows. It was to be published in 2018, but hasn't been the follow-up to the RHI. So a bit of a vacuum at the moment, I think, is the best way of answering your question. That's really not being tackled. And what is the big challenge, which is the existing built environment. Building new stuff that's brilliant is not the challenge. That's quite easy, as I said in one of my slides. So I hope that gives you a perspective, but there isn't really an answer, I don't think.
Anything you'd want to add to that, Roddy?
Yeah, just to echo that. First point, we haven't built a network that isn't used by the university. So we've chosen to take that step. And with gas CHP, it's been very easy because it's been very cost effective for us. But in a new paradigm, which is what we're looking at, where we're looking at a counterfactual of gas against a renewable source, we shouldn't be doing that. That's not a reasonable price comparison horizon, I think, as Dave was mentioning. So I think we need to be thinking about the policy horizon supporting connection, and I think that's coming forward through the Heat Networks Act in terms of requiring connection to a heat network that's available and that is clean, not based on gas. And I think that will require connection, but I think we need to encourage that connection as we all know and understand, and think about what that price point is and what the other metrics are that support that new discussion, I guess. So yeah, that's an interesting and developing discussion. We do think about how that metric and that business case is presented in the work that we're doing just now, and the benefits of connecting to a clean heat source. People want clean energy, clean heat, but the price issue is still there, I think. So we haven't got to the bottom of that yet, but we're very conscious of it.
Great, thanks very much, both. Well, we've got a question that I think.
May I just jump in? Sorry.
Yeah, go.
Just a couple of points on the policy, because in what I do, I hear a lot about the policy developments here, even though we're not a heat network operator. The zoning policy concept that Roddy's talked about has been sitting in the wilderness for many years. I feel that's now coming in. So the idea there is that a heat network pays for itself better if everyone uses it. But do you have an obligation in the zone to use the heat network? And the answer now is potentially yes. That's not confirmed. It's not through yet. But the understanding is it has now changed, that there is actually a lot to be said for zoning. The flip side of that is customer protection, of course. Because not all heat network operators actually behave well. Some are not good and don't protect their customers in the way that they should. The Heat Trust was set up to answer that. It is presently a voluntary scheme run by the ADE. It has a lot of members, but there are a lot of schemes that are not members. And we are aware of moves to require regulation and customer protection in those schemes, and that will answer the other side of the zoning question. On the gas counterfactual side, another policy idea that's in play right now, if you look at electricity is loaded with costs associated from greening up electricity, whereas gas is not loaded with that, apart from very small amounts. And one of the debates presently that's going on just now is, where should that policy burden be? Should it be on electricity or gas or taxation or what? The outcome of that is not known. But I think it is expected that the burden of green policy costs should not be on the one energy vector that can actually solve the net zero challenge. So that will shift, and potentially some of it might land on gas, which changes the picture there. And finally, the greener you make the grid, the cheaper electricity becomes. And we've seen this. If you're talking about a lot of capacity in offshore wind, which is a major government target both for Holyrood and Westminster, then you are going to see far more availability of cheap electricity in far more periods of the day and the year.
Great, thanks guys. Next question I think would be towards you, Alastair, from David Healy. Is that the natural progression from the present national balancing mechanism actually local energy markets?
Yeah, I saw this one come through in the chat, and I was thinking of typing an answer to it, but it was too good a question to waste. So I thought better have it live. Yeah, so I'll do a circular answer. The balancing mechanism will persist because the electricity system has to be operated in national scale, and grids are for sharing. So whoever's got the resource, the grid is there so that you can share it with those who need the resource. Nevertheless, location creates significant value potential because of the way networks are configured, because of the different ways that load and generation grow in different areas. Those markets don't really exist in large scale yet. There are a lot of players, not us, we are not a market operator, we're a market participant, but there are several new market operators trying to get that going. So Electron, Nodes, Piclo, among others, trying to push forward local energy markets in which you can envisage a community-owned wind turbine on one hand, selling electricity to the community heating scheme on the other. You can even see the same thing happening in the heat networks themselves. Why should somebody not institute a solar thermal park in some land that they've got? If forestry is nearby, why shouldn't somebody feed the same heat network with heat from there in periods when the price and thermal advantage of the heat network of the heat pump is lower? All of these things are possible. No one yet knows how that's going to play out. But one of the ways it could play out, this is why it's circular, is that the balancing mechanism could be one of the ways through which the national system can access the capacity in the local networks, and the local networks can inform the national system of what they've got and what they can do.
Yeah, I think there's a lot of work going on with open networks, with the Energy Networks Association at the moment on that, and who gets priority over flexibility? Is it the local DNO? Is it National Grid? We've been involved in a few DNO trials so far. We're currently participating in the WPD Intraflex trial with the district heat network, and what we've been enjoying about that trial is the fact that you could stack delivering flexibility to the DNO with the balancing mechanism. So the gate closure for the Intraflex product is 30 minutes before gate closure for National Grid for the balancing mechanism. So you could make a decision to offer your flexibility to the DNO before you decide to offer your flexibility to National Grid. So there's lots happening in there. I'm aware of the Centrica project that, in the southwest, and there was another local energy flexibility trial in the Oxfordshire area. So yeah, lots going on there, and lots to come through the wash in the open networks projects that the ENA is running. But yeah, I'd imagine that both the BM and local energy markets will play a form in one form or the other in future. Next question, I've got one from Robert Clark here. What sort of power prices are you expecting on Queen Key heat pumps and similar large heat pumps, and how much impact is anticipated from flexibility relative to power price?
I can give you a perspective on that again. Alastair can maybe fill in or correct some of my arithmetic on my post-it note here, which you can't see, but here you are. So if we have 1,000 kilowatts of power demand, and electricity is 15p as an example, that's £150 an hour. Heat pumps typically are sized to run about 3,000 hours per year, which would be £450,000 of electricity bill per year. We know from some work that we've done, and from the interesting district heating land to the Raleigh Mundane frozen chips, and I won't say who for, but big UK supermarkets, their cold storage facilities can be switched on and off, just as we're proposing here. But it's worth approximately, and this is where Alastair will either say way more or way less, sort of Bruce Forsyth style, but it's about £75,000 worth of earnings or bonus if you agree to make 1,000 kilowatts absolutely switchable through the year. And that equates to about 16% of the cost of that £1,000 load running 3,000 hours per year. So there's my post-it note, but it's roughly about 16% in my opinion, but it might be higher, might be lower.
The order of magnitude is absolutely right. I mean, that's where it's going to be. So, for example, if you have a heat network that is going hell for leather to meet demand, then switching it off may not be possible at certain times. If it's oversized, it's just too big for the load that's presently connected, then flexibility might be most of what it does. So you will see range in that percentage, but the overall numbers are sort of reflective of where these markets are tending to be just now. The one thing I would add, though, is that Queen's Quay, for example, is north of the border. There is a significant constraint in the transmission network between Scotland and England. On any windy day, there are wind farms being taken down for the price of a renewable obligation certificate and the cost of electricity and a small amount of margin. So £70 a megawatt hour being paid to those wind farms to not generate. That is money on the table that is not factored into the calculation that you had there of the cold store. So locational factors push that up in particular cases, Scotland being one large particular case. There are also moves in the south of England to open up that, because there are transmission constraints there now. It's going beyond distribution into transmission on the solar side, and there's wind there too. So if you get wind and sun on the same day in the south of England or in South Wales, then there's the similar sorts of numbers are on the table.
Great, thanks very much both. A question here, can we get the slides? Yes, we have recorded the webinar, so we will make the recording available to everyone in a couple of days, and I'm sure we'll be able to send out the slides as part of that. A question from Nigel Alwyn Forster for you, Alastair. What is the minimum level of heat pump capacity which is required for some sort of DSR benefit, i.e. of interest to an aggregator? Our projects are all in schools and most are below 1 megawatt.
We have told National Grid and we've told the Energy Minister, and I'm telling you now, that we will, fingers crossed, go live in 2021 with domestic electric vehicle chargers participating in the balancing mechanism. A domestic EV charger is 7 kilowatts in size. That's smaller than a domestic heat pump. So Nigel, smaller than whatever you're going to build is the answer. Aggregation is what solves that. With the EVs, clearly we're talking about initially hundreds of EV chargers. Now there's a little bump in the road there, which is that for most of the market opportunities, we do need that megawatt. Not for all. For some, we need 100 kilowatts. But for most of the market opportunities, we need that megawatt. But it can be an aggregated megawatt, aggregated within a distribution zone. And when I say a distribution zone, there are 14 of them in GB. So that's the ones that you know of as your distribution network operator zone, the first 2 digits of your meter point administration number. So we can aggregate, and 1 megawatt is not a barrier if you do that.
Absolutely. Just to add to that, clearly one thing that we in terms of the aggregation of 7 kilowatt EV chargers, for many of the people on this call who have worked with Flexitricity and continue to work with Flexitricity, they're used to our large outstation cabinets that we ship to sites to interface with CHPs and so on. Clearly that is not possible with each individual EV charger. So typically we're working with the platform provider behind those EV chargers. I won't name any names here, but if there's a platform provider or EV charger installer that has installed 1,000, 2,000 EV charge points or 1,000 heat pumps across a particular area, the platform, kind of like a Hive type platform for heat pumps, can control each heat pump or EV charge point individually. We will connect to that platform via an API and dispatch through the platform, but clearly we're not going to be installing bits of hardware on every single EV charge point or domestic heat pump across the UK. But Nigel, we'd be happy to chat to you about the projects that you're working on and if there's a way of interfacing with those assets. The next question is from Ben Whittle. If we assume a low temperature domestic heat pump can deliver heat at a 4:1 ratio or 45 degrees, what is the typical COP penalty of using the higher temperature heat pumps operating at 80 to 100 degrees? And you'll have to excuse me because I don't know what the acronym COP stands for, but hopefully Dave will be able to fill me in on that one.
It's to do with good cop and bad cop, or coefficient of performance. It's an interesting question that hasn't got an easy answer, so I'll try and keep it brief. I don't think we'll see district heating networks above 80 with big heat pumps providing them. It's far better to make the buildings better insulated and to drop the network temperature down. We get quite obsessed about this. Every 1 degree that we can lower the network flow temperature saves 1.5% of the electricity cost, so the COP goes up by 1.5%. So we're always aiming for 75 or 70 or even lower. The challenge for cities is they're a blend of old and new. And Queen's Quay is a perfect example of that. There's the old buildings that were designed for 82, 71 with gas boilers, and the new stuff that, yes, absolutely could be individual heat pumps or small clusters of heat pumps with very low flow temperatures at 45 degrees. But what makes the whole city work is when the whole city works together. And so taking a blend of this. So long story short, we will see COPs in the order of 3 or slightly above if the flow temperature is 75 to 80 versus that, yes, very, very low temperature, 45 degree if it's a brand new house that's really well designed. But the bigger the network, the more benefit that actually comes from it. So one thing I was going to say earlier that's not unrelated is you can actually also use the buildings as part of the thermal store. The reverse is being done in Texas, where the energy company is forcibly turning off people's air conditioning when it's very, very warm and the power demand is very, very high. The same could be done with these buildings. Fast forward 10 years, Strathclyde University, lots of buildings connected to district heating, and the grid gets a bit tight. A signal goes out to each of the building thermostats. Knock it back 0.5 degree, please. And all of a sudden the demand disappears on the network and the demand disappears in the heat pumps. Equally, well, look, electricity is really cheap. I know you're going to need heating in about 2 hours time because the lectures are starting, etc., etc. Knock it up 0.5 degree. And it's only what lots and lots of people are doing in their domestic houses when they're playing around with the domestic tariffs. So it's a really, really interesting space. I think we're not even scratching the surface of it yet. But it all does come back to efficiency and cost of heat. And networks are really for buildings that are in areas of high density, probably not all that suited to domestic heat pumps as individual heat pumps. So big clusters. And as I said, the challenge is not how to do 1 or 2 buildings zero carbon. It's how to do all of them zero carbon, and that probably means a compromise across a city block.
Great, thanks, Dave. There's an interesting point that's come through on the chat from Matthew Black about a project that Kensa are doing using small domestic heat pumps and responding to the Octopus Agile half-hourly tariff. That kind of brings up a good point about when you use the heat pumps and what signals you respond to. So the Octopus Agile half-hourly tariff is clearly a wholesale market signal. Flexibility kind of comes in behind that. So in the balancing mechanism, can you beat the prices that you can get in the wholesale market by responding to market signals from National Grid? But I think the big kind of underlying point that is we always need to acknowledge is the end customer and the requirement for heat. So how, and I don't know if Roddy, Alastair, or Dave are ready to be able to touch on this question, but how do you balance those market signals from wholesale markets, from balancing the balancing mechanism and network needs, and then ultimately keep the customer's house warm and satisfying their heat needs? Alastair, I think you've raised your hand, so I think, are you wanting to jump on that first? I'll
keep it brief on Agile. I am one of many energy geeks who have been trying out Octopus Agile in their homes to see how it works. It's an excellent concept. It seems to have gone a little bit wayward lately. It's been a bit on the expensive side, but there may be some temporary reason for that. I don't know what it is. I think the point to make, though, is that Octopus Agile is a tariff. It's set at, you find out your prices, I think around about 5 p.m. for an 11 p.m. start for 24 hours. So that is the day ahead auctions. And responding to day ahead information means you don't know anything about what happens within day. So was it warmer, colder? Was it sunny or less sunny? Was it windy or less windy? And were there any events? Did France disconnect? Did Belgium disconnect? Did Torness sit down, which it will do from time to time? And the place that you respond to those signals is intraday, which is also a wholesale market, and the balancing mechanism. You can't respond to an event that hasn't happened yet, unless you've got a crystal ball. And the other point is that Agile contains locational signals in the fixed distribution costs and transmission costs that are fed in through the sort of the formulae that the network operators agree with Ofgem. They don't contain locational signals that relate to today. Only the balancing mechanism contains that. So, for example, you will pay a lot to consume electricity over the evening peak on any tariff, whether Agile or any of the others. But if it happens to be the case that you're in a windy place and it's very windy, that price is false. That's sending you the wrong signal for what you need to be doing with your electricity consumption. The balancing mechanism recognizes that and can give that locational signal. None of the other wholesale markets really have location in their structure.
Perfect. Roddy, is there anything you'd want to add on that in terms of the experience you've had at the University of Strathclyde and the projects you're running in terms of how you use wholesale market signals, potentially flexibility signals, and ultimately look after the needs of the campus for heat?
Yes, I would love to be able to respond in that positive manner. However, I would admit that, like many in the city, we don't fully understand this market. And I think that's an issue, to be honest. I was going to, kind of offer that up as a user who's trying to balance operational need and spaces being correctly heated, correctly cooled for user experience versus the need to decarbonize. And I think that this conversation today is really helpful because it brings home to me that, I'm not at a balancing, I would never know anything to do with balancing mechanisms and all the technical stuff that we're talking about here. I'm just a punter trying to decarbonize the estate and make it real and build a case around the financial imperative and benefits. And I think there's a real opportunity for experts on this call to fill that vacuum, because I think I'm not the only one. I'm not a numpty. I do have a bit of an idea, but I think there's a gap in that knowledge piece, and I think it comes back to the gas discussion. Well, we can't afford decarbonisation, but actually there are other benefits to this agenda, and there's a whole systems approach that we need to be taking here. That's what we're trying to do. But I think this discussion has been hugely helpful today to let me see into that insight, because it's a huge help to the overall discussion and narrative. And I think Scottish Government would if they're on this call, I don't know if they are, but I would think their ears would be perking up, as this is a way to help deliver the agenda at a national level. It's definitely part of the picture. So I'm ignorant and ignoramus on this, so I stop there, but I do see the bigger picture as being hugely helpful here if we can get into that discussion.
Great. Well, there's an action for us, Alastair, to potentially take away and see if there's anything we can do to help support that conversation. We're always looking for next ideas in terms of webinars and things we can host. So it's not just applicable to heat pumps. We've talked about the electrification of transport as well. There's certainly areas that we can pick up on there. So thanks very much. There are no other kind of outstanding burning questions, so I'll just ask the panelists. I see Roddy's got his hand up. Any panelists want to add any kind of final thoughts before we finish up?
Well, could I ask a question, please?
Of course.
A selfish question. So I'm asking on behalf of a friend. So if I was a rural community and I was thinking about talking to my neighbour who's developing an idea for a large-scale solar array on land in a community setting, and I'm an engaged community member. I've got an energy development trust, and I want to engage with that developer. And I've heard of this thing called the balancing mechanism and local generation and decentralization of energy. So yeah, I would be thinking, how can I engage with that conversation? What should I be asking the developer to think about? So that's sort of an open question, maybe that you could respond to it, at least at some level. I don't know.
I may have got that one.
I was going to say, Alastair, that sounds like your domain there.
Obviously, the first thing is to get everyone in a room and do the optioneering. We often find ourselves in discussion about co-location, where a site does two things at once, and in some cases that's about sharing a connection. So a battery on a wind farm is or a solar farm is actually becoming a more common concept. Sometimes the sites are just nearby. They may even be next door, but they have a separate point of connection. And if they connect into the distribution networks, then in one sense they might be 100 miles apart, and it's the same arrangement. So navigating that change in arrangement between a site where it's really one site and simply neighbours is an important part of dealing with the rules around this. And I think when you set out the sort of the call for clearer information on this, one of the points that entered my head was that the difference between technically good and bad things to do versus what the rules say and how you navigate them, they're entirely separate puzzles, and a lot of our time is spent identifying the technically sensible thing to do and finding a way to do it within the rules as they're currently written. Now, two sites next to each other, like I said, grids are for sharing. Get the best out of the solar farm, get the best for the heat network. Run them separately, because according to the rules, they are separate. There are things you can do. You can have agreements between the two in terms of they can help to secure power prices for either for the solar or for the heat network, whichever it is you're actually trying to protect, because they have opposite needs in those markets. If they are actually on one site, then you start to think about the clever stuff, and you start to think, well, some people would put a battery on that site. I'm going to put a hot water tank. Why not? And that's when you start to get the engineering into the room. So that split, is it one site or is it two sites next door to each other, is where you start in that discussion.
Thank you. Very helpful. Thank you. I'll tell my friend.
One closing comment for me, I suppose, or two perhaps. Roddy very nimbly shifted the conversation from the cost of energy, which is the entirety today had been about cost, and started talking about carbon footprint. And that's a really interesting thing to keep in mind, is that we've got two masters, if you like, that we're trying to satisfy. And at the moment, I'm not sure we're doing a good enough job of satisfying either of them, but we want to satisfy both of them. There is some correlation between the carbon footprint of electricity and the cost, but it's not absolutely connected. So I wonder if at some point in the future there might also be effectively volunteering of load shifting based on the carbon content, where people are opting out. But at the moment, frankly, the legislation tells us to use carbon data from 2012. So we're not even really up to speed with what the grid intensity is. But I can see electrical loads being shifted in the future based on the carbon signal that comes as well, where a university with sound morals, etc., or targets might choose to buy some electricity at a time of day that was more expensive, but it helped support the grid by being lower carbon. So that's my first comment. The second one is, I think it's a little bit like trying to play tunes with an orchestra. You can't do it until you get all the instruments on, or at least some of the instruments onto the stage and start conducting them. At the moment, the challenge is Queen's Quay is the only network like this in the whole of the UK for this sort of client. There are others that are bigger they're feeding horticultural facilities, and there are others that are lower temperature. But until we get enough instruments onto the stage, it's going to be very hard for the experts to produce a market mechanism to manage how to use these. So we're kind of just being total chancers and picking up on what is happening for other reasons in the electricity market. But until we get enough instruments on the stage, it's going to be really difficult to say district heating plus heat pumps equals this outcome, because it's simply not enough members in the orchestra as yet.
If I might come back on a couple of those. Sorry, this is turning into a two-way. Apologies for that. It is more difficult to. There are problems in drawing a correlation between carbon intensity and the price you pay for electricity. That is absolutely true. There is a correlation, but it's not as strong as you might think. However, the correlation between carbon intensity and the wholesale price of electricity is stronger, because it is not confused by fixed or separately dependent network charging signals and so forth. So that's one of the reasons why we take flexibility into the flexible markets. Take it beyond the wires, and then you pick up the carbon, and it is actually quite a strong correlation, to the extent that the renewable generators get really annoyed by it, because actually when they generate, they actually depress the wholesale price, which costs them money. Yes, that as you can imagine, that would annoy a developer, but that's your job. Your job is to push that price down. And in terms of the many instruments on the stage, yeah, absolutely right. However, while we don't have a full string section, we got a couple of saxophones up there already, in the form of some CHPs, some batteries, some large energy users, some water companies. You can actually make music, with a mix of instruments that might look a bit odd just now, and we'll get to Mozart in due course.
I'm hearing the cantina from the Star Wars thing.
Thank you for.
Well, I thought that was a great analogy to end on. So unless anyone has any further comments from the panel, I'll thank everyone very much for the time today. It's been a really interesting, really interesting presentations, and I thought the Q&A really brought out some interesting things as well. So thanks everyone for your time, for participating. As I mentioned earlier, we have been recording this, so that recording will be made available in due course. We'll see if we can send the slides out as well. There's a few action points on the chat and in the Q&A that we'll pick up on. Somebody responding to Roddy's point earlier about the help with the right people to speak to within the Scottish Government, and a couple of people wanting us to follow up with them individually. So it's been a really useful session today. We thank you all very much for your time, and I hope you have enjoy the rest of your days. Thank you. Bye-bye.